as a machine system, but an augmented machine and biological system. In the case of farming, the biological components are in at least 2 species, but in reality, when you think about things in the soil and everything else, it's actually dozens or hundreds of species involved. And I think we need to take a systems approach when we think about solving problems like this. And on that basis, perhaps this is an example of what future farms will look like. In this case, this is a farm in Japan that grows lettuce and is expected to increase productivity 25x over the next few years, and nutritional content several times as well, for lettuce that is grown with very little human involvement, but is conceived as a system where humans and machines work together to produce crops. So whether it's inside a factory like this in Japan indoors, growing crops for human consumption, or it's many acres of soybeans or corn grown across wide swaths of land, I think it will be an augmented human-machine system that will bring about future yields. Thank you.
Eric, I know we're meant to be talking about augmented intelligence in agriculture, but I can't resist asking this question. I looked at your formula. What kinds of genetic interventions are going to be necessary to increase crop yields with cultivars? Are we going to have to use technologies like CRISPR-Cas9 to create entirely new cultivars?
I think we're at the early days of actually optimizing the genome for the environment. I think one thing to keep in mind is that we can selectively breed and optimize plants for particular environments, and we can optimize plants for the environments we have today, or we can optimize plant genomes for the environments that we expect to have 7 to 10 years from now.
Which will require direct gene editing, probably.
Well, humans have been modifying genes of plants for a very, very long time, usually doing this process with inefficient means through selective breeding.
And slowly, too.
And slowly, yeah, and it's become faster and faster from selective breeding and looking at phenotypes and then using Mendelian inheritance to infer genotypes to actually sequencing genes and using a marker-assisted selection approach. And I think increasingly we'll see with some of these technologies like CRISPR more direct editing. In fact, in some crazy future world, it would not surprise me to see a planter that will print a genome for the plot of earth that could be the size of this stage, that's optimized for the expected growing environment of that season, accounting for the jet stream, accounting for El Nino, accounting for climate change, and accounting for the complex soil, which includes complex biological systems at time of planting.
Okay. I enjoyed that. Let me ask a question that actually is relevant. Your predictive model is essentially only good as the sensors that you have, which means you require the full cooperation of the farmers. So how do you convince farmers that embracing this augmented intelligence model really will increase their productivity?
That is a very good question, and that's why I think of it as a human-machine system and not just a machine system. The short, pithy answer is very carefully. In my experience, it's hard to come from San Francisco to Illinois and tell a farmer that the way his grandfather and his father applied fertility may not be optimal. And oh, by the way, it's your 1.5 million on the line, not mine. But I'm from California, so trust me. And but you can have the conversation. I think farmers are very interested in optimizing their operations, and they care very much about obtaining the best outcome. And I think if you can communicate in a way that makes sense with their experience and using a language that makes sense, and you can prove on the basis of having done this before in the field for real that they're very amenable to experimenting. I think one thing that's interesting as we think about statistics and machine learning is that statistics was invented in many ways, modern statistics, for agriculture 100 years ago now. And I think it's interesting to see it come circle and apply some of these machine learning methods with some of the traditional statistical methods through experimenting on farm to kind of demonstrate efficacy of production practices.
So case studies for farms that they recognize as being farms like this.
Exactly. Yeah, and farmers, in my experience, are kind of the ultimate experimenters and tinkerers. They love to try a new technology. If it works, they adopt it. We saw that with things like the self navigating tractors, and we saw that with new seeds. And if they can do an experiment on their farm and they see that it works, they will adopt the practice.
Eric, I'll have you back in a sec. Thank you.
Thank you.